calculate the expected value, variance, and standard deviation for the probability distribution shown below. Just use the values from the previous example because we can see that this is the same distribution for x that we had in the previous example. And therefore, we have expectation of x is equal to 2, which we could have got because of the symmetry anyway. Var x, that is equal to 0.5, and SD of x is 0.707, just the square root of 0.5, correct to 3 decimal places. Now consider the probability distribution of y. And this time we can see the y values are 10, 20, and 30. So going from here to here is multiplying by 10. So when we want to write a relationship between x and y in the form y equals something x, we can say, well, y is equal to 10x. We then want to calculate the expected value, variance, and standard deviation for y. Again, using symmetry, we can see that the expectation of y is going to be 20. Now, if we think about the variance, what we're going to do is expectation of y squared, take away the expectation of y squared, and so that would be 10 squared times 0.25 plus 20 squared times 0.5 plus 30 squared times 0.25 and take away 20 squared. And if we do that, we'll find that the variance of y is equal to 50. Then the standard deviation of y is the square root of 50, which is 7.07, giving that to 2 decimal places. Well, compare. Write a relationship between ex and ey. So expectation of y is going to be 10 times the expectation of x. Look at the relationship as well. For the variance of y, that is 100 times the variance of x. And it's important to note that that is 10 squared times var x. Remember, variance is a squared quantity. For the standard deviation, that is 10 times the standard deviation of x. What do we notice? Or not both. We notice that expectation of y is 10 times the expectation of x. The variance of y is 10 squared times the variance of x. And standard deviation of y is equal to 10 times the standard deviation of x. And why has this happened? We think about this as being our original. We have multiplied, and that has both moved the distribution, but also changed the spread. So multiplying all the values affects both the position, that's the expectation, and the spread of the distribution.